welcome back to this video session. My name is Samuel. This is the second part of the video on factoring using the sum and difference of two cubes. It is highly recommended that you view the video, the first part 1 of this video. It is highly recommended that you view that. Okay, so in this second part we shall solve the rest of the 4 questions remaining from the first part. And after that we shall now derive this formula. Okay, we talked about why we need to derive the formula, because some of you may have professors that would not give them the formula. So some professors require that you know how to derive the formula. So in that case, I will teach you how to derive it in this video. Okay, now let's go ahead and finish up what we have from 11. Number 11 says x6 minus y6. Okay, so this is what now, from what we've been talking about, this is x squared cubed minus y squared cubed. So if you compare this, a will be x squared and b will be y squared. If you compare it, a will be x squared. When you compare it, a is going to be x squared and b is going to be y squared. And when we use difference of cubes. Okay, so this will now be x squared minus y squared times x squared all squared plus x squared times y squared plus y squared all squared. Right? So this will now be, now x squared minus y squared, we shall still get to this. Let's just find this first. This is x4 plus x squared y squared plus y4. Okay, we still have something to do here because this is a difference of 2 squares. Remember what we did, and it's the product of their sum and their difference. So this is x plus y times x minus y times x4 plus x squared y squared plus y4. And this becomes your answer. Now, some of you might ask me this. What if you decide to do it difference of 2 squares first? Like, what if you decide to do it x6 minus y6 and you decide to do it x cubed squared minus y cubed squared, and you do the difference of 2 squares first before you now apply this? You can do that. You can. And you will still get the same answer. Okay? But it's pretty much easier to do it difference of cubes first before doing difference of squares. You might, if you want to do difference of squares first before doing difference of cubes, if you want to do difference of squares first before doing sum of cubes and difference of cubes, that's fine. You will still get the same answer, but you know, it's easier if you do it like this. Okay, number 12. Number 12 says x6 plus y6. Okay, so we still do it that way. X squared cubed plus y squared cubed. And of course, our a is still x squared and our b is still y squared. So, but here we're going to use sum of cubes instead. So this will be x squared plus y squared, then x squared all squared minus x squared times y squared plus y squared all squared. Okay? Now, we didn't do sum of squares. You cannot factor sum of squares unless they have a common factor. In that case, we factor by GCF, but you cannot. They don't have any common factor here. You just write x squared plus y squared times x4 minus x squared y squared plus y4. And this becomes your answer. Okay, question 13. X9 plus Y9. You can do X9 plus Y9. Yes, you can do it. Yeah. So this will be what? What do you think it will be? What do you think it will be? So this will be X cubed all cubed plus Y cubed all cubed. You know? In this case, what will be our A and what will be our B? A will be X cubed and Y will be Y cubed and B will be Y cubed. Right? And we're going to use sum of cubes. So this will be X cubed plus Y cubed times X cubed all squared minus X cubed times Y cubed plus Y cubed all squared. Right? So let's, we will still do this, okay? We'll still get back to this again, but let's kind of finish this first. So this will be X cubed plus Y cubed. Let's do it one at a time. Then this is X6 minus X cubed Y cubed plus Y6. Okay? So this will be, you now know that X cubed plus Y cubed. In this case, your A is X and your B is Y. In this case, your A is X, your B is Y. So this will be X plus Y times X squared minus xy plus y squared times x6 minus x cubed y cubed plus y6. And you check whether you can do anything anymore. And if you cannot do anything anymore, this becomes your answer. Okay? That becomes your answer. All right. The last but not the least will be what? Question 14. X9 minus Y9. Our A is, well, it will be X cubed all cubed minus Y cubed all cubed. Right? So our A is X cubed and our B is Y cubed. So this will be what now? You use difference of cubes. This will be X cubed minus Y cubed times X cubed all squared plus X cubed times Y cubed, right? Plus Y cubed all squared. Okay? So we will still come down to this. X cubed minus Y cubed times X6 plus X cubed Y cubed plus Y6. Okay? And then you find X cubed minus Y cubed. You still use difference of two cubes. In this case, your A is X and your B is Y. So this will be X minus Y times X squared plus XY plus Y squared times now X6 plus x cubed y cubed plus y6. Just leave your answer in this form, okay? This becomes your answer. All right, we finished the questions. Now let's prove this. Okay, let's go ahead and prove it. I need space, so I will erase this. I will erase everything. So I would like to use Pascal's triangle. It will save me time, but some of you don't know Pascal's triangle, so I'll probably use Pascal's triangle if I'm doing the difference of cubes. But as I'm doing the sum of cubes, let me just use your multiplying polynomials. Okay? Multiplying polynomials, I'll use it for sum of cubes, which I will do first. And then the difference of cubes, I will just go ahead with Pascal's triangle. And because it saves me time. So let's start with a plus b all cubed. A plus b all cubed. So this is a plus b times a plus b times a plus b. Let's do this two first, okay? A times a times b times a, b times b. Multiplying binomials. You can, I'm listing it by vertical method. You can do it horizontal method, that's fine. So this is a squared, ab, and b squared. So this is a squared plus ab plus b squared, which is a squared plus 2ab plus b squared. Now, let's go ahead and multiply this. Multiply a squared plus 2ab plus b squared times a plus b. Okay? Yeah, we want to find what this is. So this is a squared times a, I'm listing vertically, a squared times b, 2ab times a, 2ab times b, b squared times a, b squared times b. So this is a cubed, this is a squared b, this is 2a squared b, this is 2ab squared, this is ab squared, and this is b cubed. So when you kind of list it, it will be a cubed plus a squared b plus 2a squared b plus 2ab squared plus ab squared plus b cubed, and this will give us what? A cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just to make sure, okay, that I don't skip anything. So we see now that a plus b all cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, I'm gonna use this now to get this stuff now. Okay, I will still need to erase this. So this is a cubed plus 3a squared b plus 3ab squared plus b cubed. Alright, now let's rearrange this. Make your left to be your right and your right to be your left. So this is now a cubed plus 3a squared b plus 3ab squared plus b cubed is a plus b all cubed. So a cubed plus b cubed will be a plus b all cubed minus 3a squared b minus 3ab squared. right? So this will be a cubed plus b cubed will be a plus b all cubed minus 3. What is, you can factor this out by GCF. If you factor by GCF, 3ab is common, and what will remain? A plus b, right? So you now have that a cubed plus b cubed will be, now if you look at this now, look at these two, 1, 2. Look at these two now, what is common? A plus b is common, you see that? A plus b is common. So if you bring out a plus b common, put your bracket, what will remain here will be a plus b all squared, right? Minus 3ab. Okay, let's finish it off. So this will be that a cubed plus b cubed, this will be a plus b times, you can now put your parentheses. If you expand this, or let's do this, a plus b times a plus b, break it down some more, minus 3ab, right? Okay, so this will be a cubed plus b cubed will now be a plus b times a squared plus 2ab plus b squared minus 3ab. Okay, so we have that a cubed plus b cubed will be a plus b times, you can now open up your stuff, a squared plus b squared plus 2ab minus 3ab, and we now have that a cubed plus b cubed is equal to a plus b times a squared plus b squared minus ab. And if we want to make it to look in that form that we had from the beginning, we have that a cubed plus b cubed will be a plus b times a squared minus ab plus b squared. That helps you also. Alright, let's go ahead and do a minus b all cubed. Now, for a minus b all cubed, you can do the multiplication of the polynomial, that's fine, but I want to be a bit fast so that this video is not too long. So I'm going to use Pascal's triangle. It's easier for me, right? So I have 1, 1, 1, 1, 2, 1, and then 1, 3, 3, 1. This is what I need here. I need this row. All right? So I have that a minus b all cubed will be a cubed plus 3 times a squared times negative b plus 3 times a times negative b all squared plus negative b all cubed. I mean, this, it makes it easier immediately to get this stuff. This is a cubed, right, minus 3a squared b plus 3ab squared minus b cubed. You see that? A minus b all cubed. So this is what, if you were multiplying, can you imagine, if you were multiplying this by polynomials, you should imagine how long this would take you. I mean, you should imagine how long it would have taken you. Just this, how many seconds I took to get it. Now, if you were doing this by multiplying polynomials, multiplying the two binomials first, and then you get a trinomial, and you multiply the trinomial by the other binomial. Yeah, you will see how long it would have taken you. But I mean, use the way it's better you do the way you understand Okay, do the way you understand. So let's start from here. That a minus b all cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. Let's rearrange this. So we have that a cubed minus 3a squared b plus 3ab squared minus b cubed is equal to a minus b all cubed. So we have that a cubed minus b cubed will be a minus b all cubed plus 3a squared b minus 3ab squared. If you move this over, it changes the sign, okay? Alright, now this will now be equal to a minus b all cubed. What is common here? Plus 3ab is common here. What is remaining? A minus b. Okay? So a minus b, you bring it out, is common on both of them. You now have this and this. A minus b is common on both of them. You now have a minus b all squared plus 3ab. Right? So this will be equal to a minus b times, this is now a minus b times a minus b plus 3ab. And you know what, if you like, you don't even need, if you're using a Pascal's triangle to get a minus b all squared, it will be this. A minus b all squared, we use this here, this row. This is a squared plus 2a times negative b plus negative b all squared. Okay, 2 times a times negative b plus negative b all squared. This is a squared minus 2ab plus b squared. That's what it is. So this is now a minus b times a squared minus 2ab plus b squared, then plus 3ab, right? Okay, so we've got to finish this. I need to erase this. Pascal's triangle. I hope to get my own triangle too. Okay, so this will be that a cubed minus b cubed is a minus b times, this is now a squared plus b squared minus 2ab plus 3ab. Right? So a cubed minus b cubed is a minus b, a squared plus b squared plus ab. And if you want to put it in that form, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And this becomes the answer. Okay, folks. If you have any questions, please feel free to ask me, contact me, and ask me. And I hope you understood the sum of two cubes and the difference of two cubes. I don't have a song for this, so why don't you develop one? Okay? Thank you so much for listening.